Good morning class prep 3. We have already started in the subject of science, the book physics, and first two topics of chapter 1 we have already done. We have started chapter 1, unit 1, measurement of physical quantities, and I have explained you what are the physical quantities. And now in topic 1.3, which is measurement of length. The measurement of length, and in this topic we are going to discuss different things with which we can measure different things. I have told you the SI unit system, which is used worldwide. SI means Standard System International. So it is an international system which is used all over the world, and they have fixed some units which are used. For example, in SI unit, meter is the basic unit to use to measure length, and N is the symbol for the meter. So in SI unit, meter is used for measuring length, and in this topic we are going to discuss these few things. For example, the meter rule, the Vernier calipers, and microscopic gauge. These are three different instruments with which we can measure different lengths, because lengths can be very bigger and lengths can be very shorter. For example, it can be the length can be in the several meters, and it can be in the centimeters or millimeter. But how we can measure the lengths which are very greater, like in meters or miles or like something, and the very shorter lengths which are in centimeters or millimeters. So the first one, this table, which is present at page number 4, table 1.3, that is shown to show the length to be measured, the suitable instrument, and the accuracy of instrument. Means how much smaller unit can be measured. For example, if we want to measure several meters, we will use measuring tape. Measuring tape you have seen when you go to the tailor, they also have the measuring tape. Different engineers, when any engineer who are making the roads, they have the measuring tape as well. They measure the several meters. So several meters, if we want to measure the several meters, we will use measuring tape. And the smallest unit which can be accurately measured with the help of measuring tape, that is 0.1 centimeter. Okay, and if we want to measure several centimeter, here we have measured several meters. Now the smallest unit, several centimeters. So we use meter and half meter rule. These are used in laboratories, science laboratories. When you will come and I will take you in the science lab, then definitely I will show the meter rule. And these are the meter and half meter rule. But you know, normal in your life, you use the scales. For example, this is a scale, and it has different. For example, it is starting from 0. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the centimeters. The bigger line and numbers. For example, this is 1 centimeter. And the smaller lines are showing the millimeters. The smaller lines are showing millimeters. Okay. So these are different centimeters. These are different centimeters. And the smaller line is showing millimeters. So this is a normal scale which we use in the class to measure the different lines or different objects. So several centimeter we use meter or half meter rule, and the accuracy of the unit is 0.1 centimeter. 0.1 centimeter. It can be accurately measured. For example, this is 0 and this is 1. 0.1, it can be measured accurately. So the smallest line which is shown on the meter rule, which is shown on the measuring tape, these are the smaller accuracy of the instrument. Means the smallest unit which we accurate measure by the help of these different tools like meter or measuring tape, meter rule. And if we want to measure very smallest, that we will use, for example, if we want to measure between 1 centimeter and 10 centimeter, from 1 centimeter to 10 centimeter. So we will use Vernier Caliper. I'll show you Vernier Caliper later. Vernier Caliper. This is also an instrument with which we can measure different smallest things. And the accuracy of the instrument is 0.01 centimeter. Means more smaller than the, which cannot be, if the things are very smaller, which cannot be measured with the help of scale or meter rule. So then we will use Vernier calipers. This is the Vernier caliper. This is Vernier caliper. I will show you in detail. I will tell you the parts when we will discuss it. The next, if we want to measure the things which cannot be measured with the help of Vernier caliper, we will use micrometer screw gauge. Micrometer screw gauge. This is micrometer screw gauge which can measure very smaller things even. And if the things are in cylinder shape or round, we can easily measure with the help of screw gauge and also with the help of Vernier calipers. Because if we want to measure the diameter of a smaller ball, it is impossible to measure with the help of scale, because the cylindrical or round or spherical things cannot be measured with the help of scale, but with the help of screw gauge and Vernier calipers, we can easily measure the cylindrical or the ball form shape. Okay, the accuracy of this micrometer screw gauge is 0.01 millimeter. Here is 0.01 centimeter. Millimeter is the smallest unit from the centimeter. Centimeter is the bigger unit as compared to millimeter. So the accuracy of this instrument is 0.01. It means very minute or very smaller things can be measured with the help of micrometer screw gauge. So now we are going to discuss these three instruments in detail: the meter rule, the Vernier calipers, the micro screw gauge. Come to your book. Your book, page number 4, second paragraph. This is meter rule. We have discussed the meter rule as well. This instrument is commonly used in laboratory to measure the lengths of the object, such as wire or distance between 2 points. Distance between 2 points, that is measured by the meter rule. To use the meter rule, it is best to measure from the 1.0 centimeter mark. See, this is a plastic scale. This is the point 0. But the meter rule, these are made up of wood, and sometimes if it is used again and again and again, the zero can be maybe that is not visible. So it is very if we want to measure, for example, we want to measure the length of this pencil. So what we will do, we will not going to start from the 0, we will start from the 1. Why? Because by the use of the meter rule, maybe 0 has torn from the scale, or maybe these are not visible. So it is good to measure. We will start from 1. For example, see, it is almost 15. If we are going to start from 1, it is almost 50. Okay, more than 15. But what we will do, we are going to start from 1. Actually, we should start from 0. But from the meter, if we are using meter rule, we will start from 1, and then this 1 will be minus from the total, so that the accurate measurement should come. Okay, see, I'm going to read it for you. Come to the second paragraph, meter rule, 4th line, and then third line. Use the meter rule. It is best to measure from the 1.0 centimeter mark and then subtract 1.0 centimeter from the reading at the other end. This is because for most meter rule, the 0 mark is at the very end of the rule. Wear and tear of the meter rule may render this mark suitable for measuring purposes. So we will start from, if the 0 is visible, we can start from 0. But if the 0 is not visible, we will start from the 1, and from the total value we will minus 1. Okay, next, for accurate measurement, one more thing. While measuring the things, sometimes parallax error comes. What is parallax error? Parallax error is the error which can occur by the vision. For example, if we want to measure, for example, this. If we want to measure the length of this one, we will see vertically. We are starting from 1 and we will see vertically. Means if we are measuring from here, the parallax error can come. But if we are watching, our eyes should be totally vertical at the angle of 90. We should see. So at the angle of, for example, at the angle of 90, we are watching, we can easily see the edge of this pen, this marker. Okay, but if we will measure from here, it can be like here. So the error which is due to the vision, that can be called as parallax error. So to avoid the parallax error, we always see vertically. We always see vertically at the angle of 90, then this error would not come. So for accurate measurement, the eye must always be placed vertically above the mark being read. This is to avoid parallax error, which will give rise to the inaccurate measurement. For example, see the book. This is totally the eyes are at the vertical angle. Eyes are at the vertical angle, and this is the accurate measurement. But if the eye is not placed at the vertical angle, then the error can come. Okay, this is the parallax error. See the book carefully, and then you will understand what is parallax error and how the parallax error can occur. Okay, the next is Vernier Caliper. The next is Vernier caliper. Let's see what is vernier caliper. For example, I want to show you vernier caliper. The diagram of vernier caliper is present at your book, page number 5. See these. See, these are the inside jaws. This is the main scale, which is starting from 0 till 100. Here is another scale. This is called vernier scale. These are the outside jaws. The main part of the vernier calipers are inside jaws, outside jaws. This is the main scale and this is the vernier scale. So we will discuss the steps, how we will measure the things. First, see the vernier caliper. These are the inside jaws. These are inside jaws. These are outside jaws. See here, this is the main scale. This is the main scale, and see, it is the vernier scale. This is main scale and this is vernier scale, which is starting from the 0 and ending at 10. Okay, this is called vernier scale. So why the main scale and vernier scale are present on the vernier caliper? When we measure anything, for example, if we want to measure the diameter of external diameter of the board marker, if we want to measure the external diameter of a board marker, so what we will use outside jaws. We will use outside jaws. We will place it and we will set it like this. We will just tighten it from here. Let me set it. Okay, for example, if we want to, for example, here, the external diameter, for example, this, the external diameter of the board marker. Okay, here it is the external diameter of the board marker. First, we will just hold the thing which is going to be measured in the external jaws, outside jaws, and then we see the main scale. After that, we will see the vernier scale. We will add main scale reading and vernier scale reading, then its total diameter will come. For example, these are different steps. These are different steps. For example, this is the first step. Let's see the first step. Step 1 is grip the object. In this case, a ball bearing. Gently use the outside jaws of the clippers. These are the outside jaws of the vernier calipers. So just hold or grip the object into it. This is the first step. The second step is read the main scale directly opposite the 0. This is the main scale. This is the main scale, and see the 0 of the vernier scale. See the 0 of the vernier scale. For example, this is the 0 of the vernier scale. This is the 0 of the vernier scale, and the opposite it is 3. Okay, and the line which is touching the main scale with the vernier scale, the line which is touching the main scale with the vernier scale, that is 3.1. See the step. Read the main scale directly opposite the 0 mark on the vernier scale. In this case, the reading on the main scale is 3.1 centimeter. or we can say it 31 millimeter. So we have written 31 millimeter. This is the second step. And the third step, see the vernier scale. Third step, see the vernier scale. This one is, see, step 3 is the fourth vernier mark. See, this is 0. This is almost near to the main scale. That's why we have taken 3.1, 31 millimeter. We have taken this line from the main scale. Now we are watching vernier scale. This is 0, 1, 2, 3, 4. Fourth line is touching exactly. So we will see the line which is more closely to the main scale. So here 1, 2, 3, 4. So 0.4 millimeter. We will write this. This is a vernier scale. And the fourth step is we will calculate, we will add the main scale into vernier scale. Main scale is 31 millimeter. Vernier scale is 0.4 millimeter. When we will add main scale and vernier scale, the diameter of this object would come. So this is the fourth step. 31.4 millimeter is the diameter, outside or external diameter of the ball. Okay. So in the same way, if we want to take the internal diameter, for example, if we want to take the internal diameter of this marker, okay, so what we will do? We will use this one. Okay, so it will be the internal diameter. It will be the internal diameter. First we will see the main reading. We will write the main reading. Then we will see the vernier reading, and we will add main reading into vernier reading. So it will be the internal diameter of the lid. So if we want to take the internal diameter, we will use the inside jaws. These are called inside jaws for the internal diameter of anything, and these are the outside jaws for the external diameter of any cylinder. So the process for the internal diameter or external diameter is the same. We will take the main scale, then we will take the vernier scale, we will add these two, and then the diameter will come. Next topic, which is the micro screw gauge. This is micro screw gauge. See, this is micro screw gauge. See, this is micro screw gauge. I want to show you the main reading and the thimble reading. At this, when I will tell you the different parts, then you will know this is called the thimble reading, because this is called thimble and the reading on it is called thimble reading. So for example, it is going to start from 0. It is going to start from 0, then 5, then 10, 15, 20, 25, 30, 35, 40, 45, and from 45 till here, these are the 50 division. These are the 50 division on the thimble reading. And now see the main reading. This is the main reading. This is the main reading. This line, this vertical line, these vertical lines are showing the reading, and this horizontal line, it is showing the main line. Okay, and that is called datum. This line is called datum. This line is called datum. I'm just going to scroll it for you just to show the complete readings. These are 25. These are 25. See, 25. Okay. So these are the main scale reading or datum line. This is the datum line, and on the datum line, this is the main reading, and this is the thimble reading. So again, like the vernier caliper, we will take the main reading and the thimble reading. We will add these two, and then the measurement of the thing which we are going to show, that will come. So this is called okay, let's see from your book. Let's see from your book at page number 6. See the micro screw gauge. This is called anvil, spindle. This cylinder form portion is called this is the main scale. This line is showing the datum, and this portion is called thimble. The scale on the thimble is called thimble scale, and this last part is called sleeves. This is called sleeves, and the scale on the sleeve is the main scale, and the line is called datum, and this is called spindle, and this is the spindle reading, and this is called ratchet. Okay, so how we can measure a very smaller ball? For example, this is a very smaller ball, and we will just fit it into the anvil and spindle. First we will move this one, and then we will move ratchet until it's vice. Okay, now we will take the diameter of this ball. Yes, see the steps from the book as we have discussed. That step 1, turn the thimble until the anvil and the spindle gently grip the object. Then turn the ratchet until start to click. The ratchet prevents the user from exerting too much pressure on the object. Next, this is the first step to grip the ball. How to grip the ball? Next, second step is read the main scale. This is the main scale, which is shown very visibly over here, although it is present here, but it is shown. See, this is the first line, and these are millimeters. First, second, third, fourth, fifth, sixth, seventh, 8.5. See, the ball which is shown in the book, it has the main scale 8.5 millimeter. Read the main scale from here, from the datum, and then this is the vernier scale. This is the spindle scale. Second step is that, third step. Third step is, now the thimble scale has 50 divisions, as I have explained to you, each of which is equal to 0.01 millimeter. 0.01. These are the smaller scales. 0.01 millimeter. Take the thimble reading opposite to the datum. See, this is a datum line, and the point where it is exactly meeting the thimble scales. Okay, so that is 40. That is 40. See, take the thimble reading opposite the datum line of the main scale. In this case, it is 40 divisions. It is 40 divisions, but which gives the value of 40 multiplied by 0.01, because 1 shows to 0.01 millimeter, that will be 0.40 millimeter. So 0.40 millimeter will be added into 8.5, which is the main scale. Then when we will add these two values, it will be the diameter of this ball, which is 8.90 millimeter. This is the fourth step, that reading, sleeve reading, and the sleeve reading plus thimble reading will show the main complete reading of the diameter. So these are the different steps which are shown in the book, and we can easily take the value of the ball. See the figure 1.9. This is the datum line, and it is exactly equal to 0. It is exactly equal to 0. It means no zero error. For example, see, when we close it, for example, it is exactly, this is the datum line inside, and this is the 0. If it is exactly equal to the 0 when the anvil is closed, so there is no zero error. There is no zero error. See the book now. Here, datum line is exactly equal to the 0, no zero error. So see here, we say that there is no zero error if the 0 mark on the thimble scale does not lie directly opposite to the datum line of the main scale as figure 1.10. There is no zero error, then it will be exactly the reading which will come, that is exact. But if there is zero error, for example, see this, 0 is here, but it is after 0, 1, 2, 3, 4. 0.004, 0.003, sorry, ये 1, 2 and 3. See this is 0, 1, 2 and 3. It is, the datum is meeting at 3 after 0. So what will be zero error is 0 plus 0.03 millimeter. All measurement should be reduced by 0.03. What he is saying? He is saying that take, if it is showing the plus 0.03 error, then what we will do? We will take the value by adding these two, and then we will minus 0.03 from the whole value. Then it will be the exact value of the ball. Next, see, if it is before 0, for example, this is 0 and it is before 0. So how much it is? 1, 2, 3. So it is minus. Okay, 0 error is minus 0.03 millimeter. All measurements should be increased by 0.03. Then we will add 0.03 in the total value. So I'm just going to read it for you. Figure 1.10. The zero error is 0 plus 0.03, okay, millimeter. That is to say, all measurement should be reduced by 0.03 millimeter, and the value obtained from the figure 1.8 then become 8.90 plus 0.03. This will be 8.87. Okay, due to the zero error of plus 0.03, it will be reduced from the total value. 0.03 when 8.9. So 0.03 is reduced, then it will be 8.87. Okay, so I hope that you have understood how to use the micro screw gauge, and if there is zero error, how to add or how to reduce the value, and then the actual value would come. Let's come towards the homework. Yes, I have given you homework. First question is, why we use meter rule and how can you avoid parallax error while measuring length with the meter rule? You can take the help from page number 4, topic the meter rule. Second question is, write the 4 steps while measuring a ball with the Vernier calipers. The 4 steps which we have discussed at page number 5, figure 1.6. So these 4 steps will be the answer of this question. Question number 3, write the 4 steps while measuring a ball with a micrometer screw gauge, page number 6. You can take the help from page number 6, figure 1.8. So this is the way how we can measure the bigger values and very smaller values with the help of meter rule, Vernier calipers, and with the help of micro screw gauge. Take care and Allah Hafiz till the next session.